Hello everyone. Through this interesting video, let us see some of the engineering applications of the physics concepts that you have mostly studied during your 12th classes. One such application that we are going to discuss today is the working of a xerography machine. And the physics concept behind this machine is electrostatic charge and field. Now, this is the overall diagrammatic representation of the xerography machine. Now, this xerography machine, the paper that has to be photocopied has to be placed on the scan mirror. And as you place the paper on the mirror, there is a halogen lamp fixed at the bottom of the scan mirror that entirely scans the document. And this halogen lamp reflects the image that is to be photocopied through a lens onto a secondary mirror, and from the secondary mirror the image is reflected onto the main portion of the xerography machine known as the photosensitive drum. Now let us see the explanation of this further in the next slide. Now here you can see, as we saw in the previous diagram, the major components of a xerography machine is a halogen lamp. This is a scan mirror on which you place the document to be photocopied, and here you have the photosensitive drum. This is the toner unit, and this is a conveyor belt that is used for loading the blank paper through the feeder here. Now, as the image is scanned on to this photosensitive drum, here you can see that the photosensitive drum is a metal roller, and on top of the metal roller you have a coating of a special photoconductive material known as selenium. This selenium is a semiconductor, meaning which when it acts as an insulator in all the dark areas, that is the areas which is not reflected by light, and it conducts electricity on all the areas that are reflected by light. So you can see that as the drum rotates, the white areas reflect electricity and the dark areas do not conduct electricity. Now suppose this is the page that has to be photocopied, and if this page is placed on the scan mirror, and if halogen lamp falls on this image, this is then reflected onto the photosensitive drum. When it falls on the photosensitive drum, the white areas reflect light and the black areas do not reflect much light. So this is what happens on the photosensitive drum surface. So all the white areas that reflects light becomes positively charged, and they are conducted. They conduct electricity. Whereas the dark area that has not conducted much light becomes negatively charged, and we get an image known as an electrical shadow. Now, this electrical shadow is nothing but the negatively charged ions that are there on the electrostatic drum. Now, as the electrostatic drum rotates, the electrostatic drum reaches the toner unit here. Now, as the drum consists of negatively charged electrical shadow, the toner ions are positively charged. So, these toner ions are attracted towards the electrical shadow, which are negatively charged. So what happens is these toner particles get stuck to the electrostatic drum, thus forming an inked image on the drum. Now as the paper is fed and as it passes across the conveyor belt, the paper also becomes charged. And as the paper reaches this portion of the drum, the inked image on the drum is stuck onto the paper. Now, this paper passes on through two hot rollers, and because of the high temperature and pressure applied by these hot rollers, the inked image is permanently fused onto the paper. Now, thanks to these hot rollers, because of which the photocopy that we receive is warm and cozy. This video is prepared and brought to you by the Electrical and Computer Branch of Karunya Institute of Technology and Sciences, Coimbatore. Thank you for your time.